Yeah, it's kind of like the second part. You can switch it up to 10-1b. Okay, let's get started here. What we've looked at so far, you've been identifying the vertex. You've been identifying the vertex. Does anyone remember what the definition of a vertex is? It is the
point where they meet.
Where they turn.
Turning point. It's a turning point. And it can be at the top of the parabola if it opens downward, or it can be the bottom of a parabola if it opens upward. Okay, so the vertex you've been able to find. Then we also looked at minimum or maximum values. We looked at minimum or maximum values. If the parabola opens downward, it has a maximum value. That means it can't go past this point. If it opens upward, it has a minimum. That means it can't go below that point. So these two things we looked at. And then we also looked at, does it open upward or downward? So those are the three things we looked at yesterday. Ma'am?
Do parabolas not have a slope?
No. Okay. You can get an infinite number of slopes based on 2 points. You can get a slope. Like, it's too complicated. There are tangent lines, we call them, that can identify or that can relate to the parabola, but we're not doing that. That's beyond us. But the parabola itself does not have a slope altogether. It has infinite number of slopes. Yes?
We're talking about up and down.
Yeah, opens upward like that, and opens downward like that. Mm-hmm.
Well, can you have like a side for it? Yeah, like this.
Like a Pac-Man looking thing? No, parabolas don't do that shape. So we don't do that, thankfully, because that gets complicated. That would get complicated. Okay, today, listen up. This is what we did already. We're going to review this, but we're also going to look at today. This is new stuff. We're going to look at domain and range. And trust me, this is going to be a lot easier than it was in the past, especially for one of them. It's going to be really easy. So that's domain and range. And then we're going to look at what we call the axis of symmetry. Axis of symmetry, which sounds like very bad, but it's not. So that's the axis of symmetry. We're going to look at that today. And then we're going to look at x-intercepts. X-intercepts. So we're looking at these two things. And we'll do it in that order. Domain and range first, then axis of symmetry, then x-intercepts. So I said at least 5 things, but because really these two relate to one another. But I'm going to give you a little hint here. The vertex gives you a lot about everything else. The vertex gives you a lot about everything else. The opening upward and downward, that comes from one part. But the vertex, now that I think of it, it gives you 4 of them. And then the x-intercepts you can find just by looking at the graph. Okay, so this is our goal, to get these down. All right, let's look at an equation here. Let's look at 2x squared minus 12x plus 11. So f of x equals 2x squared plus or minus 12x. Yeah, good. The answer is there. Yeah, f of x is functional notation. So that means that this is a function. Do you guys remember what a function is? Something that passes the vertical line test. So this graph passes the vertical line test. It has to, because it's a function. But you could have also put, Jack, you could have put y equals all that. So we got to use them interchangeably. Okay, this is what I want you to do. I want you guys to tell me if this opens upward or downward now.
Downward, upward.
Okay, good. You got the word part right, but you need to get it's upward. It opens upward. And who can tell me how they know it opens upward, not downward, because it's really 50-50. Yes?
Well, I was just going to ask that question.
Okay, who has the answer? Okay, the A equals 0. Now look at this equation. Is this standard form? It's standard form, right? So the a value is 2, and 2 is greater than 0. Or you could say 2 is a positive number, opens upward. Good. Okay, now what I want us to do, and this is going to be tough because this is our first time actually sketching one out, is we're going to sketch a parabola. You need to follow me. This is what you need to do. You need to draw the coordinate plane, but draw it in this way, where you have the longer negative y-axis, longer positive, y-axis and x-axis. And let's go by ones. You should go down to like 7 and over to 7 that way. I'll go to 8. Max, you're asking for more homework. Sorry, sir, I caught part of your question.
So, does it have to always be like x? Could it be like v or c?
It could be other variables. It could be or it could be q of x equals 2b squared, but it has to be in that format. Yep. Where the highest power of the exponent is only 2. Okay, your first point I want you to put is at 3, negative 7. Put it at 3, negative 7. 1, 2. I'll do my best to put it in the right spot. 1, 2, 3, 4, 5. Okay. And by the way, you're not doing this on the homework. We just need to look at a graph, and the more accurate, the better. Put another point at 1, 1. At 1, 1. Yeah, up here somewhere.
What was the first point again?
That's 3, negative 7. I'll label it. 3, negative 7. And then I wanted 1 at 1, comma 1. And then just one more point at 5, 1. 5, 1. 1, 2, 3, 4, 5. So this is not what we're doing today. We're not sketching, but the reason I'm doing this is because we need to look at a graph. Okay, what I want you to do is I want you to draw a parabola and do your best here. It's not going to be perfect, but watch how I do it if you're not sure. You see that? It's like half of a parabola. And then do it again on the other side. That's the other half of the parabola. Okay, so that's what it should look like about. You're not graded on it. I'm not testing you out, but it should be this. Yeah, some of them look really good. Okay, and by the way, how do I know if it's like a really skinny parabola or like this really wide parabola? Well, we're going to figure that out on Tuesday. We need to figure that out, but today we're just sketching. Okay, it opens upward, doesn't it? What's the vertex?
3, negative 7.
Yep, I gave it to you. You know it. 3, negative 7. Okay, that's your vertex. And then somebody tell me the either minimum or maximum value. So it's one or the other. Can't be both. Yes, Sophie?
Is it minimum?
It's the minimum value. And what is that?
Negative 7.
Okay, how do you know it's negative 7?
Because it's at the vertex and negative 7 is smaller than 3.
Oh, okay. It is the vertex. We're looking at the vertex. And all you have to do is look at the y number. That's the minimum or maximum value. So in this case, it's minimum. So we'll put minimum value is at negative 7. Okay, you guys okay with that? The low point is at negative 7. Okay, what we're going to look at right now is what we call the domain and the range. So I'm going to put here domain, D, and I'm going to put the range, R. And I'm going to give you some encouragement. It's not that hard. Okay. I'm going to explain this, and then I'm going to show you how you can actually do it. Okay. Look at my order pairs here. The 3, negative 7, 5, 1, 1, 1. Okay. The x values, the x coordinates, 3, 5, and 1. If you're looking at this graph, what does it do as it keeps going up? What does it keep doing as you go up? It gets wider and wider and wider. When does it stop getting wider?
Never.
Okay, it never does. You know why? Because it continually expands on the x-axis, right? Okay, you guys see the x-axis, it keeps getting wider and wider and wider. Okay, so when we're talking about domain, do you know what values we're talking about? Remember, what is domain? What should that get in your mind? Domain, x values. What can the domain be? It can be any
Any x value.
Okay, and here's how you put it. The domain can be any real number. And that's a classification. Like, again, there are fake numbers. Well, no, there are not fake numbers. They're imaginary numbers. So we're just saying they can be any real number. That means this. How many ordered pairs are on this parabola, by the way? Even when you go, it's infinite number. You know what the x number could possibly be? It could possibly anything. It could be any number. It'll be sometimes 5. It'll be 1. It'll be 3. It could be 6, 7, 8, 9, 10, 11, 12, 13, 14, 1 million, 1 billion, 1 trillion, whatever. And the same thing on the negative. It could be negative 10, negative 20, negative 100, negative 10,000, negative whatever. It could be anything, right? But the range is not any real number. Okay, here's how I want you to write it. The range on this graph in particular, you'll see a pattern. The range would be written, and I hope you remember this, y is any number such that. Do you guys remember that notation? We call that set
pair
builder notation. That's a long time ago. Oh man, that's so long ago. Okay, set builder. Okay, y is any number, and this low line means such that y. So look at the y values, like negative 7, 1, both of those. Y can be anything except, well, I should say this. Y can be a lot of things, but it cannot be anything less than negative 7. So the way I describe it is this. Ready? Y is any number such that y is greater than or equal to negative 7. Where did I get that negative 7? From the vertex. It can be any of these y values. It can be negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 1, 1, 2, 3, 4, 5, into infinity. But it can't, you know what it can't be? Sad y value. It can't be negative 8. Is there a point here down here at negative 8 for the y axis? It can't be anything below that because of the vertex, or you could say the minimum value. Okay.
Can it be negative 6?
It could be negative 6 because that's above negative 7.
If it's a downward facing graph, would it be like y is less than or equal to?
Yes, it would be, this would switch to y is less than or equal to whatever the maximum value is. So yeah. Okay, let's look at page 247. I'm not drawing this next one because it takes a long time just to sketch it. But here you have a note for yourself. This is the minimum value, so y could be anything above it. Okay, but look at page 247. Look at the bottom right. I need everyone's eyes glued on the bottom right graph. Do you see the equation? F of x equals negative x squared minus 4x minus 5. Some of you, there's no possible way you could see it because your eyes aren't there. There you go. All right. That graph opens.
Downward.
You know why it opens downward without looking at the graph itself? What's a value? Negative 1. All right, good. You got that one. That means it has not a minimum value, but a maximum value. It can only reach up to this point. And what is the vertex of that graph? Negative 2, negative 1. Good. Negative 2, negative 1. What can the domain be?
Any real number.
Good. I don't think that was it. Oh, is that it? Oh, nice. All right, here we go. And I sketched it. It's awful, but it opens downward. The vertex was negative 2, negative 1. The maximum value would be, it's right there, right? What's the domain? Any real number. What's the range? No. The range is always going to look in this format. Okay, ready? Y is any number such that y is less than or equal to negative 1. Whoa. Where did they get that negative 1? Can it be anything below the vertex y value? Yes, they can. That's where I have to get it. Hello? I can. Yes, I do. Yeah, no problem. Who's the lucky one today? Oh, okay. Bye, Sydney. So I am done at 14 minutes and 53 seconds. So, see if she heard that. Okay, do you guys see that the y value, you can get up to -1, but can you get to 0 on the y value? No. Can you get to 1 on the y? None of those. So it has to be anything below that. That's all the domain range is. Okay, I want you guys to do it on page 249. Page 249, look at number 8. I want you to get me the vertex, the minimum value, the domain, and the range. So this is number 8 on page 249. Give me those 4 parts. No, but it has nice bounce.
Yeah.
And this is again.
Pick any number for domain, or do you try number 8?
Let's go through it. Number 8. What's the vertex?
2, 2.
Okay, so 2, 2. That's the turning point, 2, 2, and I hope you get that one. What's in this case I already gave it to you. It's the minimum value. It's positive 2, so you put minimum value equals 2. And you got that from this as well. Even though they're the same number, you got it from the y value. The domain, automatic answer, any real. Yeah, that's the answer for everyone. Because think of it, it's opening downward. Could the x coordinate ever be 6?
Yes.
Yep, 7, 1,000. Okay, -5. Okay, it can always be any number. But what can the y values be? So here you're going to put it like this: R, the range is any number, is y is any number such that y is
Greater than.
Less than or equal to.
Is it greater than or is it less than? Greater than or equal to 2. You didn't even need the graph on that. You just needed the minimum value. Do you see how the vertex gives you the minimum value and the range value? So you see how that works? So far the vertex has been very helpful. Parker, can I see you after class? All right, yes.
So if it's any one, it's going to be greater than, less than?
Yep, you can think of it that way. And if you want to write yourself a little note, that's fine. But you can even look at the graph and say, it can be anything above the vertex or it can be anything below the vertex. So,
Is there a parabola shaped like a V?
yes, those are like straight, like a V. This is more like a U, but there are V's, and those are absolute value graphs.
You have any that go like straight up, like they go like
line?
that?
Wait.
Like
are you?
box?
How wide can
It's
they
like a box.
Okay, yeah, that's what that is in geometry, and some of your siblings are in geometry. It's basically 4 lines or segments, and they all have their own slopes, they have their own lengths, and they're related in certain ways. So yeah, you can, but they're not. It's not one object; it's many objects. Okay, I think I didn't need this.
Why is there so much stuff?
Okay, let's go here. Okay, the next thing we're going to look at is not this. I'm just going to create a blank one. The second thing we're going to look at is what we call axis of symmetry. For some of you, this might be a hard thing to do. It would be for me if a teacher asked me to do it, but do your best on it. I want your best butterfly. Just draw me a little butterfly on your paper, just as best you can. A butterfly. And it's a butterfly, listen to me, face on where its wings are spread out. I don't want you drawing me like a butterfly that's landed on the nose of Bambi. I want a butterfly that's spanned as just a regular butterfly. Boom. Mr. A, can I draw like all those cool shapes on? No, just draw a butterfly.
Bambi tastes great on the grill.
Honestly,
I just ruined it.
That's so rude. Why are you disgusting?
I'm not. I don't. Venison's delicious.
We banned Jack.
Right.
Why draw the little eyes?
Benny didn't achieve that venison.
I'm going to draw a fan.
You didn't ban
Jack, this is totally a butterfly, right, Jack?
What is that?
It looks like wrong.
Not a butterfly.
Don't look at Max's butterfly.
Yeah, I don't even want to look at yours, all right?
It's not even a butterfly.
It looks like you got a commercial with the log.
Yeah.
After you got smoking.
Now that I look at it, oh. Okay, now listen, you got Mr. A's best. I didn't even draw it for them. I just kind of said it. But yeah, now that I look at this big lump right here. Okay. If you drew a butterfly, or really, I could have said this, you draw a person that's just standing up and you have a straight on shot of them. It's a lot of objects, but a butterfly is a nice way of putting it. A butterfly is what we call, or a moth or whatever, an apple with a worm sticking out of it. Okay, I don't know what you want to call it, but these objects, they have what we call a line of symmetry. They have a line of symmetry. So where if you had an image of it and you fold that image in half, what do you get? The same thing. It's the same image. And you're like, okay, that's a butterfly. But one example is like a frog. You guys know that? Did you guys dissect last year?
Yeah.
Okay,
Elizabeth wouldn't do it.
okay, I don't mind stopping here. The reason why you dissect, for example, frogs is they're animals, guys. They're not us. But they have a lot of similarities to humans, as in how their organs are placed, what they look like. So you can study almost like you're studying a human at a very elementary level to actually studying the human. But the thing is, frogs are symmetrical. You are, for the most part, symmetrical. Not perfect. Yeah, but you are symmetrical from the outside. Yeah, neither is a frog. It has organs here that it doesn't have here, but the image of it, the image, which you keep saying. This right here is called, in our parabola, the axis of symmetry. That's what we're calling it. Axis of symmetry. It's where you fold the parabola in half. So now, let's draw a simple parabola. And you can make a downward opening. And just draw me the axis of symmetry on your parabola. Yours might be wider, might be skinnier, might be longer, but the axis of symmetry for mine would be... Okay, remember that vertex? The vertex is somewhere on that line of symmetry. Yep, so that's what you have. The vertex is that point. Guys, by the way, the vertex is always a point. And the axis of symmetry is not a point, but it's a line. And I do a dashed line because we understand that it's not the line we're looking at. We're looking at this thing, but this is the line we're using to fold it in half. Okay, so let's look at, let's go back to page 249, please, 249. And look at number 8. Yes, I said look back at number 8. Okay, we didn't look at the axis of symmetry, but it is there. You see that little green line running through that problem? Yeah. That line is where you would fold that parabola in half, and you would get the same image. So if it's a line, like this one or this one, you can write an equation. And on this, number 8, so I'm going to add another screen. Number 8, that axis of symmetry, and I'll abbreviate here, that axis of symmetry is equal to x equals 2. X equals 2. And you're like, because it's what? Yeah, sorry. Yep.
This is a practice fire drill, which will begin immediately. Again, this is a practice fire drill for all students.
Fire drill, we're going to pause.